Okay, we are going to determine our forces first. So I'm going to take this diagram. I'll start on the next page. Why am I on this page now? Sorry, okay, my bad. Okay, so now we are going to determine. Okay, we're going to determine our AX and AY. Okay, so this is our AX, and this will be your what? AY. Okay, so AX will be equal to cos 10 times 10 to the power 3 multiplied by cos 60. So this will be equal to 10 to the power 3 5 times 10 to the power 3 Newton. And then we have AY is equal to 10 times 10 to the power 3 sine 60. 8.66 times 10 to the power 3. Okay. So let's do something simple first. Okay. So given that material 1 is our brass, so E of brass will be equal to 104 times 10 to the power 9 Pascal. And material number 2 is for steel. So we know that E of steel is equal to 200 times 10 to the power 9 Pascal. So the first thing we're going to calculate, we're going to determine stress X due to axial loading. Okay, we are going to determine stress X due to axial loading. So the formula that we're going to use is this formula over here. This formula will be provided. Okay. So I'm going to copy the other image across so you can see what we are doing. Okay. So we are going to find stress 2 is for material 2. Material 2 is our steel. So stress X for steel. This is the easy part. Okay. So your PX is equal to what? 5 times 10 to the power 3. Then we are going to do E1. E1 over here represent our what? Our brass. So it's equal to 104 divided by 200. I get rid of the times 10 to the power 9, okay, because they cancel out. A1, okay, so the width of A1 is 0.15. And then the depth, the thickness of the flange and the web is 10 millimeters, 0.01. And then plus A2, so this is 300, over here is what? 290. Okay, so this is 290 over here. So it's equal to 0.29, or I would like to do the width first. So 0.01 multiplied by 0.29. Okay, and then we close bracket. Okay, so from here we get 104 divided by 200 times by 0.15 times by 0.01 plus by 0.01 times by 0.29 by power 3 divided by 1.359 times 10 to the power 6 Pascal. And the fact that is positive, this is positive. Okay. Positive, why? Because it's under what? Tensile. Because AX, right? AX is pulling which way? It's pulling towards the right. If in the term test, the question comes like this, what will happen? It will be under compression. Are we clear? Okay, it's not just plugging in formula. You need to know plus or minus. Are we clear? Okay. So, yes. For this case, not important yet. Yeah, because it's E1 over E2. And then if it's for the other material, it is the other equation. Not important yet. It's only under bending that is important. Are we clear? Okay. So from here, we are going to find stress X of brass. So again, 5 times 10 to the power 3. Cross-sectional area of 1. Material number 1, which is brass. Plus, by now, it will be E2, which is steel, divided by 104. Multiplied by the width. Okay. So this will be equal to 0.15 times by 0.01 plus by 200 over 104 times by 0.01 times by 0.29, 5 power 3 divided by. So it's equal to 0.707 times 10 to the power 6 Pascal. Okay. So that is the value that we get. How do you know it's right or wrong? I'm very ambitious, okay? I want to train you as really good engineers. Yes. Say it again. No, for Excel, no. Because you have E1 over E2, E2 over E1, depending on what. How do you know you are right or wrong? Yes. Simple. Think simple for me, please. Yes. Can you describe a diagram for me that can show you that this is the case? A diagram. Daniel. Okay, don't put you on the spot. Save Daniel. Think something simple. That's why I derived the equation. What rule do we apply? Hooke's law. Yes or no? We apply what law? Hooke's law. And what do we make an S out of you and me? What did we make an S out of you and me? We assume that what? What do you assume? Which one is brass? The steeper one or the more gentle one? What do we assume? What do we assume? Jawohl. You know, these things are good checks. Okay. If you got opposite, at least you know you do something wrong. Are we clear? Okay. But does not necessarily help to check on your magnitude. Okay. Think what? Evans, think what? Think simple. Are we clear? Okay. Whatever I teach you is not that difficult, but you have to know your what? You have to know your fundamental. Are we clear? Which means what? Fundamental will make you go what? Crazy. Are we clear? You have to know your what? Fundamental. See, I got nothing better to do than form words like this, okay? Right. So now this is the easy part. This is purely plugging in what? Formulas. Next, we have to determine. Okay, we have to determine stress X due to what? Due to your bending moments about My and your what? Mz. So to write out the general formula due to bending moment, you have stress X is equal to N My over Iyy multiplied by Z. Okay. So for this course, what I taught you is don't worry about what? The sign. Okay. Just take it easy first. Breathe. Okay. So the first thing that we have to do, we have to determine what is our IZZ. Okay, we want to determine IZZ. Okay, so we have to determine. So what we don't know is we don't know this, 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 we don't know this. Okay. So first we are going to determine our IZZ. And I'm going to pick the reference material. Remember you guys talked about reference material? Reference material as our material number 1, which is going to be our what? Brass. If you pick your reference material as steel, the answer should be the what? Be the same. Are we clear? Okay. So now, looking at this diagram over here. So I'm going to call the top part our flange. The bottom vertical part known as our what? Web. Okay. Then we go into section. Okay. So section, we have our flange. And we have our what? Web. For this case, the table need to be more extensive. We call the next vertical line or next column, we call as our material. So the material of the flange is made of brass. The web is made of what? Steel. And from here, we calculate our N value. This is 1. This is equal to 200 over 104. Okay. And then from here, the next thing we do, we put our N multiplied by width. That. Okay. We are going to determine IZZ. ZZ axis is horizontal, so this is your what? Width, and this is your what? That. Okay. So it's going to be 1 multiplied by our width is equal to 150. Depth is equal to 10. So this will be equal to 150 times 10 is equal to 1500. The next one, 200 over 104. The width is 10. The depth is 290. Okay. So 200 divided by 104 times 10 times by 290 is equal to 5.576 or 5.577. 577 times 10 to the power 3. Then we have the next vertical one. And now this will be equal to your Y bar. Okay. So I'm going to take my Y bar from the top, i.e. my datum is at the what? At the top. You can take your datum at the bottom, you'll still be fine. Okay. So this is 10 divided by 2, and this is equal to 5. This will be 10 plus by 240 divided by 2 is equal to 240 divided by 2 plus 10 is equal to 130. No. Is it 240? No, 290, sorry. 290 divided by 2 plus by 10 will be 155. And then finally, sorry, this thing has to move or come down, okay? And then finally, you have your N, W, D, Y, okay? So 1500 times 5, 7500, and then 5.577 power 3 times 155 is equal to 864.4, 5.577 power 3 times 155, 864.435 times 10 to the power 3. Okay, then you do the summation on your final column. 1500 plus 5.577 power 3 is equal to 7077. And then over here will be equal to 7500 plus by